Welcome back. Problem 7-13. So statement is determine the maximum shear stress in the strut if it is subjected to shear force of 20 kilonewton. So here we have shear force of 20 kilonewton. Clear, all the dimension of strut is given. So you have to find the maximum shear stress. So let's start with the solution. As we know that maximum shear stress is equal to V max or V into Q max divided by I into T. So first we have V max, we do not have Q, we do not have I, we have T. So we will first find I. So I is section property. So section properties I will be equal to, now you can see how we will find I. So first we will take it as a whole, this rectangular section. So it has total width of 120 millimeter, so it will be 120 millimeter. So in term of meter it will be 0.120, and total height is 84 millimeter. So in term of meter I have written it is 0.084, and then we will subtract these two, the moment of inertia of these two portion, hollow portion. So I is equal to 1 over 12 B. So B is total this one, which is 120. So 120 is 0.120 meter into height, which is 0.084 power cube, minus 2 times 1 over 12. Its breadth is 20 millimeter. So 20 millimeter is 0.02, and its height is 60 millimeter. This portion, this height is 60 millimeter, so which is 0.06 meter cube. So again, when you solve this, you will get this I, and this I comes out to be 5.207 into 10 raised to power minus 6 meter power 4. So this is the value of I. Okay, now we will move toward finding this Q max. So Q max is equal to, you know that this is equal to, if you take this upper half section from the neutral axis, this is neutral axis, so this is the upper half section. So here we will divide it into two portion. So first portion is this one plus the second portion. So we will first find Q1 for this and Q2 for this, and Q max is equal to Q1 plus Q2. So I will write it Q1 plus Q2. So let this is 1 and this is your 2 portion, and that is equal to Y1 dash into A1 plus Y2 dash into A2. So Q max is equal to Y1 dash. So if you are in taking this half section, so you can see that this height is 0.03, which is 0.06 divided by 2. So I will write it over here. This height is equal to 0.03 meter, and its width, which is 80 millimeter, and this width is 80 millimeter. So in term of meter is, it will be equal to 0.08. So this area of this portion and the area of this portion is equal to 0.08 multiplied by 0.03, which is its height, and what will be its y1 dash. So this is 0.03, so its half will be y1 dash. So this will be y1 dash. This y1 dash will be equal to 0.03 divided by 2, and that is 0.015 meter. Plus, now we will take this area. So you can see this area is 0.005 0.120 multiplied by 0.012. So I will write it 0.120 multiplied by 0.012. And what will be y2 dash? So y2 dash will be from neutral axis till the mid of this section 2. This is y2 dash, and this y2 dash will be equal to 0.06 plus 0.012 divided by 2, which will be 0.036 meter. I will show you. If you take the half, so this half will be equal to 0.012 divided by 2 plus this, which is 0.06. So it will be 0. Not 0.06. This half, sorry, this half. This is 0.03 plus half this one, which is 0.006 meter. So it will give you 0.036 meter. So again, when you solve this, you will get Q max will be equal to 87.84 into 10 raised to the power minus 6 cubic meter. Now you can find the maximum shear stress. So maximum shear stress is equal to V into Q max divided by I into T. So we have V that is given as 20 kilonewton. So 20 into 10 raised to the power 3. We have Q max is 87.84 into 10 raised to the power minus 6 divided by I that we have calculated over here is 5.207 into 10 raised to the power minus 6 multiplied by thickness T, which is 0.08. So you can see the thickness where we have shear force V is applied. So again, when you calculate this, so you will get 4.22 into 10 raised to the power 6 Pascal, or you can say tau max is equal to 4.22 megapascal. So this is the answer of our this question or problem 7.13. I hope you have enjoyed this video and also learned from it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.